Okay. Yes, please. I see a hand raised. Okay, so yes, yeah. Johnson, please, you can come in.
Anyway, anyway, happy Independent Day to all, and I'm glad to
Yeah,
join the
same to
rest of
you.
this class. Thank you.
Same
I
to
want
you.
to
Please,
ask: is there?
please send your celebration gift to us too. Send your akuko nam to us too.
Okay, I think Mr. Doctor, I do take off that. Thank you.
Oh, okay. We are
I
happy for that.
I'm a lone ranger here. At times I hear a child and leading.
oh, it's because you don't really know why I work or what I do, so that's fine. That's okay. Um, please, I want to ask. I want
Yes,
to ask:
Mister.
is there any is there any standardized decimal place that maybe the journal has not specified it could be used?
Okay. I'll be straightforward with you. I'll be straightforward with you. Mostly,
Okay,
we
thank you.
go with 3 decimal places. 3 decimal places. Sometimes it becomes tricky if you are reporting a T statistics that sometimes can be only 2 decimal places. Okay, but there's the specific standard of journal requirements. You go with 3 decimal places. 3 decimal places. You see the how do you call it? The p value, the significant level is always at 3 decimal, right? It's always at 3 decimal. So it is mostly advised that we go with the 3 decimal spaces. Is that okay?
Okay, that's fine. Thank you.
Mhm. Please, any other? Okay, so let's continue. Now, then let's see, this is how the data is moving. Let's see the correlation analysis of the data. Let's see the correlation analysis of the data. We talked extensively on correlation the other time. We talked extensively on correlation the other time. So, but today we can simply run Pearson correlation analysis. So we choose our descriptive statistics. We go to statistics, then we go to the summary, descriptive, and then we come to the correlation analysis. We have the partial, Pearson, interclass correlation. All these correlations, I would advise that you can just go read on them yourself, and then you choose the one that is good for you. Sometimes we choose the correlation analysis also based on the literature. We choose the correlation analysis based on the literature. Some of them suppress rigidity. Some of them suppress sampling method bias. Some of them give room for minimal error. But mostly, the Pearson correlation is mostly done. So we click the correlation analysis. Now, basically, we always begin with our dependent variable. Okay, Dr. Adu, I'm taking it again. Statistics, summary, and descriptive. Then we come to the correlation side. So I go with the Pearson correlation. Now, I pick the dependent variable. Now, and I want to go with this, 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 and this. Okay. So I just need some few. Now, sometimes you can also, to make the descriptive statistics very, very important, sometimes let us add a significant level to it. Significant level to it. I tell you, ladies and gentlemen, you can write a paper only based on descriptive and correlation analysis and make a very good argument with it and have a good paper. I say again, you can write a paper with only descriptive statistics and correlation analysis and make a very good argument. How do we do that? That is why I started by using the additional statistics display. And then I'm doing the correlation. I'm also trying to print significant level for each entrant. So I just click here. When I click by within, I don't need anything here. The weight, I don't need anything here. Okay, I can decide to add frequency weight. Then I'll click it. The one I want the frequency weight for, I click it. Okay, I can click any of them that I want a frequency weight for them, or I can click an analytic weight for any of them. The one I want the analytic weight. So this is why I said that you can actually do this to work. Okay, you can actually work on this and then present in your paper. Okay, but first of all, let us do the general one, and then we'll come and see this weight side, and you see what I'm talking about. So it is straightforward. I click this one because we'll come back to it. I click submit. Now, you see the descriptive, the correlation analysis. The last time we talked about this multicollinearity in it, we also talk about multicollinearity in the descriptive, the correlation analysis, and then we say how to work about it. Either you drop it or you perform PCA for it. But you make sure your data is actually fit. Okay. Now, when you look at the data, when you look at the result, you see that this sign at the significant level attached to each of the variable, each of the correlation. The last time we talked about that, multicollinearity can happen, though the correlation can be significant. You see from here, the correlation is significant here, but there's multicollinearity in it. You see, which means that, yes, indeed, there is a significant relationship between import and export. Okay, though there's multicollinearity, there's a problem of biasness, there's a problem of unfit, there's a problem of misspecified model that will occur here. But even with the misspecify and all those things, it is still significant. Then we can rewrite a full paper on this. So, gentlemen, ladies, let us pay attention to this. Systematically, we are working on the descriptive statistics. Fine. We can also present, I know everybody know how to, so this correlation analysis, its presentation is just simple. There's nothing to wait about it. You just call it into your, sometimes I prefer to use Excel. So that I can also do my touches to it for my table to be okay. So, gentlemen, ladies, this is also one of the important issue that should appear in your data, in your thesis, in your paper, the analysis aspect. Now, I want us to go to any question on the correlation analysis idea. So here we can say that GDP growth, okay, correlates or relates with total factor productivity at 38%. At the point of 38%, and is significant. You see, and is significant. We can also say export correlates with total factor productivity at 70% and are significant. We can also say it here, significant. There is the relationship between the variable import and total factor productivity is significant, except when you look at this place, you see net export. Check when you check the impact of persistent trade deficit on Africa, one of our papers, you see that I have a paper on this. That's this result. No matter how you see it, it's really relative. Relative. Our net exports are always problematic to GDP or whatever, but this one is total factor productivity, which is also showing something which can also make me to write a paper on this variable and also on this variable separately with a different argument. So we should also take a very close look at this, and then the interpretation of it is also important. How do you interpret it? I know a lot of us here on the page are very good English scholars. How do you put English? Sometimes let me make this example. Let me bring us to our tool. It is not about speaking much. It's not about writing much. It's about writing little but technical. Writing little but technical. So STATA will helping us to understand this thing. Now, any question on this side, please? Madam Maureen, are you there?
Yes, I'm there.
Okay. Madam Joanne, are you there? Sharon, are you there? Dr. Adu, any question?
No question, but I want to rehearse with the description you were giving, like GDP growth correlates with total factor productivity at 38% at significance of 0.00, right? Okay.
So we can say that there is a correlation. There is a correlation. There's a relationship. Okay, there's a relationship. Now, there is something I also want us to go through. There's causality. Causality. Some people will say granga. A granger causality is also important when you want to report our data. Mostly, you can actually present your granger causality in the main work or report it as appendix. A case whereby you're only talking about the causal effect between this variable and that variable. You can perform granger causality. Okay. Now, I'm sorry we did not treat granger causality during the class, but I will perform it for us to see now. Please just pay attention to it. Pay attention to it. Now, when it comes to granger causality, okay, when it comes to granger causality, we say causality is to see if A can cause B, or if B can lead to A. If A can cause, if B can cause A. It's important. Sometimes we present our result, we don't know. So let's take a closer view on granger causality. The data is already in the system. So what do? We go to statistics. Okay. Then we move down to multivariate time series. Because our data is time series, we come to multivariate time series. And then we come to VAR, diagnostic tests. When it comes to VAR diagnostics and tests, we move to granger causality. Granger causality. Granger causality help us to know if actually the variable we are working with, especially if the independent variable can actually cause the dependent variable. And if the dependent variable can also actually cause the independent variable. Okay, if it can happen like that. So we come here, gradual causality. Now, the window open. The window open for us. Then we call in our variables. Oh, our variable didn't call. Sorry. You come here, I'm sorry. Okay, so before we perform the gradual causality, we first have to perform what is called the vector error correction. Vector error correction. We need to correct if there's any error in our variable or the lag level of our variable, what we are choosing, is it actually going to cause it at lag 1, lag 2, first difference, second difference? We have to perform it. Now, how do we perform it? It's the same thing that we do here. We first go back to descriptive statistics. Going back to descriptive statistics. Now, when you come to the drop-down menu, you still come to the multivariate time series. Then you go to vector auto-regression. Then we click it. Now, the window appear. The window appear. Now, we want to see if there is any relationship, if any of the variable can cause each other. The dependent variable first is total factor productivity. We call the total factor productivity, which is we all agree to be the dependent variable. Now, at this place, so we are going to call, let's say we are using only 4 or all of the variables. Let's use all the variables that we perform the analysis on descriptive for. So now for gradual causality, every variable become dependent variable. The dependent variable be variable. The independent variable also tend to be dependent variable against the dependent variable. So in this place, we are checking if all of them can connect each other. If we change the rhythm, that let's say GDP growth become dependent variable, can total factor productivity cause GDP growth? Or if you say export become a dependent variable, can total factor productivity cause export? You see, so that's why when you look at the window, you say dependent variables. Then we call all of them. We call T, FP, GDP growth, export, this, and this. Now, the hypothesis, we set 9 hypotheses. There is no lag difference between any of these variables. We are agreeing that there's no lag difference. There's no lag difference. And basically, I should have taken my time to teach this during the class. I should have. And I forgot the schedule I made. I did know this was not part of it. Abusiafo, families, can we closely pay attention to this well?
Yes, please.
Is it okay? Let's pay
Yes,
attention to this. Let's pay attention to this. It was never in my schedule. It was today when I was thinking of what to do, then it came to me to do. Are we good?
yes, sir.
Okay. So I said that the dependent variable can become independent variable, and the independent variable can become the dependent variable. Okay. So we select lag 2, which is already here. We select lag 2, and then we leave it like that. It's automatic. We select lag 2. Then we can decide to go to the model 2 of it. The model 2 is nothing important. We just want to just small sample difference adjustment, report small sample and F statistics. That's what we are commanding the result to do. We are commanding it to do small sample different and then report small sample different, and then we click it. Okay. We don't need any other thing here. The model is okay. So the time is already set. Our time is already set. Yeah, our time is already set. So fine, you see when I open the time variable, it's already set here as it's yearly. The time difference is yearly. So it's okay. Then we submit. We submit. Okay. We submit. Now, this is the interpretation of this. This is the interpretation of it. Now, you can see from this angle here, they say VAR, vector autoregression, which we can report it. Vector autoregression, we can report it as our analysis. Yes, we can report it as our analysis. We can re-report it as our analysis. Now, we are saying that the coefficient of total factor productivity with lag 1, when total factor productivity is the dependent variable, and we are using this one, the total factor productivity against this one, we are trying to see either total factor productivity can cause total factor productivity again. But you see, when you look at this place, it is nothing good to write home. So we neglect it. We don't talk about it. But we come to what? GDP growth. Can GDP growth actually, right, cause total factor productivity at the first difference, the coefficient is this. At the second difference, the coefficient is this. Okay. Now, this is the automatic regression. Like if one tend to the other one tend to the other. Yes, we are seeing it is working here. Now, we have a threshold, but since this data is not actually key in for that, we can leave it. But it's important. Let's read literature on it and see the threshold of your discrete statistics. Now, first of all, we see that the p-value 1, 2, 3, 4, 1, 2, 3, 4. That's the main issue. They are all significant. This one is significant. This one is also significant. The F statistics are also good. These are also good. Okay, they all fall within the threshold. Now we have the R square of this and the R square of this and also the R square of this, and see all the important variables are explained here. All the important variables are explained here. I will try as much as possible to make a PPT on this thing here. I'll make a PPT on it and then put on the page so that we can also see it. I'll also make a command-based PPT on it so that we can also see and see the interpretation proper of it. Okay, I'll support it with literature for us to see. We need it in our analysis. Okay, now at lag 1, lag 2, lag 3, everything. But let's now see, actually, can there be any Granger causality? Is there any form of Granger causality? So what do we do? We go back to the statistics, still multivariate, and then we come to the diagnostic text. Then we call the Granger causality. Okay. Now we only say okay. Everything is set. So we say okay. We click okay. Now, when you look at the result here, I don't feel good. I don't feel good because I didn't treat this proper with us here.
But
Okay, so
but I think it's helpful.
like this is helpful, right?
Like this, maybe later on, the big men can, the ladies can also maybe read a little about it.
Yeah.
That'll be fine. That's my
I
opinion.
apologize. I apologize seriously from me to everybody. This is really important. This particular analysis is very important. I apologize seriously to everybody. Anyway, teacher doesn't teach all. There are some students who go and find, but this is not the place. All right, Dr. Adu.
Yeah.
Please forgive me. I know you attack me.
Oh, it's okay. Yeah.
All right.
But still we are doing it, so we are making it up.
Okay. So please, you follow what I'm explaining one by one, and you get it. Now,
Right,
the key thing here for the Granger causality here is that we set the null hypothesis. The null hypothesis first said that the first null hypothesis is that this variable does not cause. This variable does not cause. Let's say total factor productivity does not cause GDP growth. Okay, and then alternative hypothesis say total factor productivity cause GDP growth. Okay, now the threshold is that if the probability test, the probability F test, you see, if it's more than 5%, we reject the null hypothesis. I say here again, we reject the null hypothesis if the probability F test is more than 5%. Please, you can jot it down somewhere. The null hypothesis states that, let me use this one for example. Total factor productivity and GDP growth. The null hypothesis says that total factor productivity does not cause GDP growth. And then the alternative hypothesis said that total factor productivity cause GDP growth. Okay. Now, our threshold for accepting the null hypothesis or rejecting the null hypothesis is that if the probability F test is more than 5%, if it's more than 5%, we accept the null hypothesis. If it's less than 5%, we reject the null hypothesis and accept the alternative hypothesis. Should I repeat that again?
Yes, please.
I repeat. We set the hypothesis for Granger causality The null hypothesis states that total factor productivity does not cause GDP growth. And the alternative hypothesis states that total factor productivity causes GDP growth. Now, for us to be able to accept or reject the null hypothesis or accept the null hypothesis, we look at the probability F test. Probability F statistic, this one. Now, if the probability F statistics is more than 5%, if it's more than 5%, we do not reject the null hypothesis. We accept the null hypothesis. So if it is less than 5%, we cannot accept the null hypothesis. So from here, we reject the null hypothesis that this does not cause. We cannot reject the null hypothesis that this does not cause because 0.17 is more than 5%. Statistician will tell you this is 17%. So we cannot. So that is the yardstick of Granger causality. I will advise that we get a time and read around it. But this is how it is run. We first run the autocorrelation, and then from the autocorrelation, then we run the VAR Granger causality wild test. So we can report this. So we can report this, the descriptive and the correlation analysis in our paper. Only these things can be report. We can report these three things in our paper and make a very strong argument for it, and we have a paper published. We have a paper published. In our thesis, it is important descriptive, correlation, and causality tests should be performed in our thesis as well. If you are doing using PLS, you are using structure equation model, PLS, you do the normality test, reliability test. All those tests are replaced by the Granger causality if you are doing OLS. If you are running OLS, fully modified OLS, dynamic OLS, this is important for you to run. If you are doing panel analysis, panel regression, your data is panel regression, panel analysis, causality is important. Causality is important because you need it for your report to report. You need it to support your argument. Okay, but PLS, structure equation modeling, direct, you don't need this. But OLS, which is the mother of regression analysis, you need these things in it. Any question so far? Any question? The silence in the class says it all.
Can you rehash the 17% probability after is what it means there?
All right. I say that if the probability F statistics is more than 5%, we cannot reject the null hypothesis. We cannot reject the null hypothesis. The secret thing here is that with Granger causality, we mostly based on the null hypothesis. The null hypothesis is what we actually that drive the analysis. So I say again, now you see that it is 17%, which is more than 5%. So the null hypothesis is accepted that this does not cause it. Alternatively, alternatively. Okay, there's no causal relationship. There's no causal relationship. But if TFP were to be the normal GDP, you see a causal relationship. I promise you, you see a causal relationship. A normal World Bank data normal GDP, World Bank data GDP growth, and this you see a causal relationship. But this is a dynamic something. So this is how it is. So Mr. Morley, Dr. Morley, it is when is the probability F statistics is more than 5%, we cannot reject the null hypothesis. Are we together?
Yes, sir.
Yes.
All right.
So sir, the now hypothesis is that no lag difference between the variables.
Exactly.
Okay.
Exactly. That is technical way of saying it. That is a very nice technical way of saying it. That's technical way of saying it. All right. So we continue. We proceed straight to a general analysis. General regression analysis.
And so
General regression
if
analysis.
I may ask again,
Yes, sir.
it applies to any research we do, always that now there wouldn't be any lag difference.
Yes.
Okay.
And then literature also support that. It depends on how you set it. You can set it your way, but the standard one is what I'm giving you, sir.
Okay. All right.
Standard one is what I'm giving you. I tell you, see, granular causality, we can treat granular causality for a week. Because when we are doing VECA model, if you are running VECA model, you need it in it. Please, I'm available anytime you want my help in any of this. Please add my WeChat and knock on my door. We can do it. Okay? I'm available anytime you need my assistant. Please knock on my door. We can do it. Are we good together?
Yes,
I'm available to
Yes.
everybody, ladies and gentlemen. I'm really available to everybody. The
please.
same way you should also be available to me. When the last time somebody said my head is big, that person doesn't know where I'll get the person. Don't worry.
So it's you who said it to me.
Yeah, I think we only said that today is the first time we saw you without cap. Thank you.
Oh, Johnson, why I could hear you no kwara.
Oh, no.
I know where I'll get you. I'll put you on the spot here. I'm telling you now, I'll put you on the spot here very soon. That's nice. This is what makes the class lively. So that when you see me somewhere, you shake hand, we will talking. That's very good. I like it. Dr. Irene. It's not there. All right, so let's do a simple analysis. Now, you see, sometimes you can do your analysis just by doing a drop down here. You see, we have linear model, linear regression. You click it, you quickly call in. Yes, you call in your variables. Okay. All right. You can decide to manipulate it here.
Kindly permit me to draw you back a bit.
Okay, sir, you can go on, sir.
Yes, please. In the model, in the result, the output interface, we had all there. So the all there is defining all the variables you included in a model.
Yes,
because
please.
when you say all,
Yes, please. Yes, please.
so that means
Yes, please.
is 0 point, I think is 0. I'm seeing you you quickly move up. Yeah, so
Yeah.
here is clearly telling us that so none of the variable here,
Exactly.
because it's there, yes,
Yes. Yes.
has no causal relation with the TFP, right?
Yes. 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 And you see, that's very good one. You see, so our result is perfect.
Okay.
Okay, it's perfect. If there's any problem, if this one is 0.005, right? 0.05, and we have there's a problem here, then our estimation is wrong. This will not mislead this. The result here will not mislead this. Okay. Dr. Molly, the result here will not mislead this. The result here will confirm these findings here.
Okay.
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 Thanks
Thank you.
for that. So I said you can also do the general analysis from the drop down here. Now, first you type a code, regress, REG. You call in the dependent variable, the independent variables. Okay, let's do only 1, 2, 3. Okay, and then we run the analysis. So regress, REG, TFP, GDP underscore growth, export and import. And then we run the analysis. We run it. We run the analysis. Now, I want us to look at this, and then we'll run it also from the drop-down menu and see if there's any difference. Okay, so we go to the drop-down menu, statistics. We come to linear model and related, linear regression or regression diagnostics. Now let's go for linear regression. Now, in linear regression, we have dependent variable as we mentioned here, and then the independent variables are this, and this. Okay. Now, we want to check if there's any form of robustness. We can suppress the constant term. When you use this place, you have other options. You can suppress the constant term. You say the constant, you suppress it, it will become minimal or it might not even appear. Let's see it. We are seeing it together. And then total excess with constant advance. Okay, total excess with constant advance. Then let's go to robust check. Robust check. We can click robust to be this. You can click the robust, which will give you all this, any of them, best of homoscedasticity, best of heteroscedasticity. Okay, we can say that it will be at the default, but we want the best of homo. We click it, we leave it, or if you are going for OLS, it's the same thing. Now, the reporting is the same. Standard at best, beta coefficient, model is okay. Now, let us submit and see. Yes. Now, look at these two variables. Look at these two variables. Now, look at these two outputs. We have the first output when we did the regression with the code, allowing constant, allowing total excess, we did not compress. We did not check for robustness with a hetero homoscedasticity. we don't check it. We are checking the general regression analysis. Now, we have the SS present, DF, MS, we have the F statistics, R square present, adjusted present, roots, mean, square residual is also present, and everything. And then when we come to our outputs, you see here the coefficients are present. We have 1, 2, 3. They are all present. And then the constant is also present. Okay, the constant is also present. But now, when we come to the second output, talking about homoscedasticity, the robustness of the model. So, you can report the OLS as it is with a proper argument supporting literature. You have your paper sell, your thesis sell through. And then you can decide to come to a robust check of the analysis. That means when we talk about robust check, you are going further. You are going further, cracking every rigidity, cracking every homoscedasticity, anything that will change the result. Okay, anything that will change the result. And luckily, or the result being so good, you see the difference between GDP growth. First, it was 0.001, which means that this one have a homoscedasticity in it. Which means that there can be bias in the result. But when you come to the one with robust check, we have 0.2 this. So which means that there is no homoscedasticity in this result. So you can either report this one without homo or with zero robust check, or you can report the second one with homo and robust check. But the issue here is that when we check our result, we do not have R squared. R squared, that is not in it. R squared is not in it. You will see some reports, some papers do analysis, and they are saying that they are doing a robust check, and you will never see R squared in it. It is not intentional. It didn't come. They suppress it. They compress it. So looking at these two, let me be fair. Let's do the second one that suppress let's best of hetero. Let's check hetero. Okay, everything is fine, and then we submit. Now, when we check both homoscedasticity and the heteroscedasticity, you see that the results, the coefficients are not far-fetched, they are the same. Okay, they are the same. And then when you also check the one with hetero, you see that our probability this side and this side, this is 10.60 and this is 9.77. You can see the difference. And then we can see the probability F has also changed here, and the probability F here also changed here. So with the robust check of the regression analysis, ladies and gentlemen, you can report this with an argument. You can also report this with an argument. You can also report this with an argument. All depend on the literature you have in your work. When you do normal regression, everything is at your disposal. But when you do it with robust check and others, things also change. Let's see if we have any other thing to suppress. Now, let's try to see if we can do cluster robust. Cluster robust. No, by the way, any question from this before we continue?
Yeah, so
Please.
okay.
Let's
Without reporting the
Mr. Doctor. Who?
without
Okay.
without reporting the R square, uh, wouldn't it create any problem or
Yeah, it will create a problem. It will create a problem.
so then that means the first one is good to report.
Okay. That means the first one is good. But I
Okay.
also want to run another analysis with the same thing, right?
Oh,
Right?
okay.
And change the variable and see if we have R squared. So after Mr. Johnson's comments, then we run that.
Okay, thank you, Doc. I want to ask concerning the cluster robustness.
Okay.
Since the data is not clustered, maybe like panel type, is that
Yes.
necessary here, please? I want to know. Thank you.
Good. The cluster robust check is basically used when we are doing fixed effects, random effects, or a panel effect. Okay. Now I want you to try it to see if it will work, because since I've introduced this, someone say, "Oh, let me go and use the cluster." Oh, we have OLS here, we have jackknife here, we have bootstrap here, but at this result, we don't have anything panel, systematic, periodic different. So gentlemen, let's try it and see if it works. If it doesn't work, then we know that yes, it doesn't pick a time series or linear time series. Okay, but not necessary. It's not necessary. Any other? Just, are you clear?
Yes, Doc. I'm clear. I'm clear now. Thank you.
Okay. All right. So let's try it and see. Let's say we say our TFP is cluster. Let's submit. You see, a TFP is cluster, but there's no different anyway. There's no different anyway. But this result actually does not augur well with our model setting. It works, but it does not augur well. So when you do this and report, you did cluster robustness, and the paper sees, the journal sees, you say, no, this is not what you are reporting at your methodology side. So if you put this in it, they will reject your paper. Okay. Now let's try the same. Let's try different variables and see. Okay, we take off this variable. Let's use inflation, education, health, and defense. We will not suppress any. We'll come to default. We will be at the default only. Let's submit. Now, then let's now go back to the terms again. Let's go back to the terms again. Now we suppress constant, total SS, suppress. Let's go to robust check. Yes, we are going on robust. Then let's go to base of homoscedasticity. Let's submit. Okay, we submitted. Let's go to hetero. We also submit. Okay. Now, there's a paper I think 2 weeks ago. I've submitted it back to the journal. The author was so smart. Okay, was so smart and reported. The author reported robust check with heteroscedasticity, suppressing the report says suppress all these things and made an argument that when it's I think if I can recall, if when you suppress the constant, the variable really explain the dependent really explain the dependent variable and made a mistake in the reportage. Okay, made a mistake in the reportage, setting the confidence at 88. 80%. Yeah, confident, 80% confident. If you see such a paper with your understanding, if you accept that paper, the journal will not send the paper to review for them again. The journal will not send the paper to review again. Because you can see that it is actually cool. It's cool. But the comment, the presentation is very accurate, but it's cool. So now let's come back here. You see, we still do not have our R square. Can I ask a question? Why is it that we are not having our R square? Probability F is perfect. Probability F is perfect here. Now, significant levels are good. Significant levels are good. If you have any R square that is high like this, it's problematic. Anyway, I think last time I talked about it. A high R square like this is really problematic. There's a question mark in your result. With a high like this, reviewers will ask a lot of questions. Please be careful about that too. Now, can somebody tell me what is happening here? Can somebody tell me what's happening here? Mr. Molly, dog.
Yes,
What do you think is happening here?
it's because we have suppressed and we have actually constrained it. We test the what do you call it, homo. We suppress the constant and we actually restrict it to robustness on homo. So does not produce the R square for that.
Okay. Mr. Collins, any idea?
At this level, I'm learning.
Doctor, I do. Don't tell us at this level you are learning.
He has said it all.
I didn't say anything. All right, so Mr. Molly made a very good point. I want us to focus on that point. We have suppressed. And then we have also suppressed total SS residual. Total residual SS. We have suppressed the model. We have suppressed this. We are not in it. It's telling us that take away the constant out of it. We don't need the constant out of it. These models are actually run to justify the coefficient of the OLS. Okay, just run to justify the coefficient of the OLS and saying that, do you remember the economics, the econs term that say that ceteris paribus, right?
Yeah. Yes, ceteris paribus.
If all things be equal.
Yes. All things be equal. And some, I remember Professor Holly from University of Ghana was saying, you don't say all things, you say all other things. What is the difference between all things and all other things?
Yeah, I think all other things is the right thing.
All other things are right thing. Yeah, because all things,
Yeah,
the variable in the model, they are also part of the thing. So all other
yeah,
things
yeah.
aside, the one in the model.
Thank you. Exactly.
Yes, I like it here. Yeah, we are learning. We are learning. We are learning. We are learning. So that was what he told me. He said that the things are also the variable, but all other things is the right way to say. Not all things are equal. All things are equal. All things, including you, are also a thing. All other things are equal. So based on the ceteris here, we run the robust check, the voil of homo, the voil of hetero. So actually, there is no big problem here. There's no big problem here. Instead, we are only concentrating, confirming the coefficients. We are confirming the coefficient. So there's something called baseline model. Baseline model without the alpha, without the constant. So baseline model, advanced baseline model is what we just ran with the robust, checking it against all odd. We've checked the result against all odd. Okay, we check the result against all odd. So it means that the stochastic is not relevant in this robust checklist. The error term, the disturbance term is not relevant in this. I say against, you can write it down. Can write it down. With the robust check with this, stochastic is not relevant here. We have suppressed stochastic, we have suppressed constant, we have suppressed residuals. We don't want to talk about residuals. But you see, when the residuals is involved, you see the result here. But without the residuals, the results are different. So there's no big problem here. The most important we are looking for is that when we're able to suppress the residual, is the coefficient significant? Are the coefficients significant? So somebody can create a table and report the OLF with the residual at model 1 and then at model 2. At the second model will not report. So the R square over there will be dashed. So when we see that the model 1 is with residual, the model 2 is without residual. But when you present only the model 2, then there's a question mark there. I say again, if you present only the model 2 without the model 1, then your result is not correct. For us to actually justify your result, present this one at model 1, and then this one at model 2, and then these two at model 3. Okay, then you can make your arguments clear. Okay, let's make an argument here. Let's make an argument here. The argument says that infrastructure imparts total factor productivity as 0.000, okay, is significant here with the constant and residual present, with all other things holding equal. We have the impact here. But model 2, checking if the results or if the model possess homoscedasticity. When the model we check against homoscedasticity, the coefficient of total factor productivity is this, which is 0.035. And the significant level is 0.008. Okay. And then when we check it against the heteroscedasticity, the result is like this, but the significant level has a problem. Okay, so we make the concluding decision that the impact of infrastructure on total further productivity is positive when we allow residual and constant terms to follow. But when we take residual and constant terms to follow, it is like this, but the significant level is like this. If they are all, which is also significant, but when we take the hetero of it, the percentage is like this, but the significance is affected. 0.01, no, it's not affected. Okay, so it is okay. So from this part, we can actually agree on this and this. Okay, agree on this and this. Let's see other different. Let's say defense. Let's make the argument based on defense. We say defense with the constant is negative, which is not significant. Agree. Without the constant and residual, with the homoscedasticity, it's like this, which is also not significant. With the hetero, it's like this. Let's look for something we can do a proper argument on. Good. Let's talk about import here. The import is 0.001, negative 0.01% at a significant level like this, impacting total factor productivity. But when we suppress residual and constant, it's 0.013, but it's not significant. The same thing here is not significant. So we make a decision now. For us to actually have a full impact of import, we should include all residual and the constant variable. We should hold all other things working, all other systems, all other factors of productivity, all other factors of growth, all other factors of the Cobb-Douglas level of total factor productivity should be in full play. Then we accept this. But if they are not in full place, we will not accept this. So, gentlemen, don't be discouraged when you have this and this and this. You can report the three of them in your model. You can present the three of them in your paper, in your thesis, and make a very good argument. I think this is also important. We can try to juxtapose it in our thesis. Are we together? Are we good? I end up confusing you.
Not at all, but the basic rule that I know in explaining the outcome or explaining results is that if the thing is not significant, you don't waste your ATP discussing it. But here, I'm seeing that you are making us explain why it was significant in one but not significant in other.
Yes. I think that's the basic rule for you not to explain. But I have transcended the basic rule for you. The basic rule is the general paper you write. The basic rule is the general paper you write. But what about going beyond the general paper? What makes your paper sell more? If I report the basic root, you also report basic root. Another person report basic root on the same thing. And I decide to go a step further. Which one will you take? Why is not significant? Why is not significant? Then somebody will now, that paper become a novel statement. Why is not significant? Somebody work on it to tell us why it's not significant. So I think, Dr. Molly, I think I agree with the basic rule, but let's not stick only with the basic rule. Let's go further. Okay.
Yes.
That makes
yes.
your paper. That makes your paper.
Yes, I understand this, but I submitted a paper recently. Okay, what I did was that I used 4 outcome variables, and I was regressing various independent variables on them. Okay, and there's one of interest. I use nutrition, commercialization, profit, and yield. So I'm on the 4 outcome variable within the model of nutrients. The key variable that was significant in all the 3 outcome variables was not significant in nutrition. So
Mhm.
when I was explaining, and when I come to nutrition, I say it's not significant, but it has a relevancy. That is the consumption of sorghum. I say sorghum, soybean, which I use as a potential element for health because protein, soybean
Okay.
contain a lot of nutrient variable. But
Mm.
the reviewer, one of his comment was that why am I spending a lot of my time explaining something that is not significant? So I'm rather wasting the space, or I'm rather trying to deliver something that is not significant. So he advised I should remove it.
If that people to come to me, my brother, I'll spend more time to read it. After you publish it, I can ask you to share it with me. I can ask you to share with me. So if it's not significant, why are you reporting it? You see, why are you reporting it? So why do you write the paper? You get it? So now it's time for us to find out why that is not significant. I say that when you write the paper, there should be novel antecedent in it. Why is not significant? That is the novelty. Everybody says significant, but yours is not significant. That's the novelty. Why is it that it's not significant? Together? Are we okay? So Wally, just for a paper to be accepted, go according to that. But when you go to some journals, they will actually ask you to report up. Okay. Any other question? Madam Maureen.
I'm learning, sir.
Are you sure you're learning?
Yes.
Okay, Madam Joanne.
Yes, please.
Are you with us?
Yeah, I just came back from class, but I'm with you.
Okay. All right. Ladies and gentlemen.
Yeah, so
But
my
I
question
wanted,
is,
Please go ahead.
I
John,
wanted
please
to
go
ask
ahead.
if the robustness check the same as heteroscedasticity?
Yes, heteroscedasticity, homoscedasticity. They are all the same.
Oh, so
Check to compress all that, to remove all those from the data,
okay.
to remove them from the data.
Surprisingly, this is what my lecture was saying today, but I didn't understand. But like as you mentioned, he even said, like you mentioned, if you do that, the error term is not needed. I'm so surprised that you also mentioned.
Uh-huh. So
Okay,
your lecturer and
it's a
I are
prophet.
speaking the same language.
Yeah,
Yeah.
the same thing, just today now.
Uh-huh.
Dr. K is a prophet.
Hey, do you? I'll get you.
You are in
Is
the
that
Any
spirit.
other, please?
prophecy?
Is that?
You are in the spirit.
No, that's not prophecy. You are a scholar.
Oh, look at you.
and the
All right.
heavyweight gate chapel.
Say again.
In a
Heavyweight, yeah.
heavyweight gate chapel.
Obinim.
How mind you? Any other question? Any other question? So, ladies and gentlemen,
Yes. So my
before the
concern, so yeah,
questions,
so my concern is that like what I want to find out is that this one we are using does it apply to all regressions or it's only the linear regressions?
this is applied to all regression. Every regression. Let me show you and see. Let me go to generalized linear model, GLM. You see, GLM. GLM model. Okay, now you see the window that open. See the window that open. You see the things that are coming out. You see these things are coming out. C log, prob log, logit log, and all these things. Now, let's go to the robust check. See the same thing here. Right? The same thing here. Now, but let's run the model and see. Let's run a model and see. GLM. Let's run a simple model and see. Okay. Let's submit first. We submit it, right? You see the submission. We submitted first. Okay. Now, he has given us our result, right? He has given us, for this one, GLM will give him likelihood, all these ones. It will give all these terms to you. So he has given us this. Let's check the robustness of it and see. Let's do a robust check and see. Robust check. Okay. The robust check. Let's submit robust check and see. You see the robust check, what it gave us. Now, without a robust check, we have scale parameter, first difference, the person, all these things. They give us every other variables, or what we are looking for. And then when we did the robust check, remember, it starts from here. You see, this is another model. Generalized linear model. Now, do you see anything R square here? Do you see anything R square here? Generalized linear model. You don't see anything R square here. Instead, we base on acceptability of the model on AIC, BIC, and all these things. But the coefficients are actually okay. Coefficients are actually okay. But generalized model, generalized linear model has nothing to do with you suppress, you change anything. Okay, but you can check robustness of it. Robust check is important. You can check robustness with all that model. Okay, but when you come to the OLS, ordinary least square, it gives you compression, allowing. But this one, general model, has done everything for you. You see, optimization, ML, we give you all the residual and everything. It doesn't change anything. Okay, for them, it works. Let's check another linear model and see. Linear model, GMM. GMM is something that you want me to check, but GMM will take a lot of time. All right. So yes, so Mr. Dr. Molly or Dr. Edu, the question he asks, we can check robustness for all. But when we are doing generalized linear model, it's the system actually builds and work it out for you. You don't need to suppress and compress. That's why it's generalized. It takes all other factors constant for you. So in generalized linear model, you don't need R square to check variance of the analysis. So far as the general linear model, you present these ones are important. Any other? I think we'll end our class today here. We end our 8-week encounter here. But I will say again, I'm available for you any day, any time. You want me to assist you for something? You want me to take a look at a paper for you? You want me to take a look at a topic for you? You want me to take a look at your structure for you? I can do it. Yeah, Mr. Martin, you can ask your question, sir.
All right, sir. Good evening. So,
Good evening.
I'm more interested in the explanation you gave about if, let's say, your result is not explaining what it has to be, it becomes a novelty, right?
Yes.
So I wanted to ask, in general terms, let's say you start working on a paper and then based on like what you wanted to do, like the the theory you wanted to use to align with your work during the literature review, it makes sense. But then after you finished with your analysis and everything, probably some of the variables and everything that came up may not really be aligning directly to the theory. So since the theory is an old theory, how do you handle it? Do you still explain it as a novelty? And will it be acceptable, or does it give a sign that you should probably look for another theory to align with it?
Okay.
I don't know whether you,
Okay.
yeah.
I get your question. I want to answer your question with this. You know, in growth economy, if an economy achieves full employment, the economy collapses. Do you know that?
Yeah.
When the economy achieves full employment, all other factors of productivity are in use. Right? There's no unemployment in the system. The economy collapses. There should be unemployment in the system to strengthen the economy. Okay. Now, but the theory states that for a country to be fully employed, all others should be working. Now, and you run your result, and you go contrary to that theory. That's a novelty you have brought. That statement, that result, that does not align with the theory. It counter the theory. It becomes the novelty. It's a serious novelty. It's a serious novelty that you should build on it, and then write on it, explain on it. So if the theory says that, you know, the mercantilism theory on international trade, it says that to be well disposed, you should sell and accommodate more gold, right? More gold, and then you become okay. The mercantilism theory. But when you look at the mercantilism theory, it is actually a myth, and it does not work well. So if you run a result, conduct a research that counter mercantilism theory, then your model, your research become a novel research that people will look on it, and somebody can also criticize it. So it is not wrong that your results contradict theory. It's not wrong. It becomes novelty. For me, where I am, if when I run a result, they contradict theory, I'm happy. Okay, everybody is supporting theory. So what is new? So I think it is okay when you have your results that stand a bit adjacent to theory. It becomes novelty. Go ahead to explain your. Okay. Now, all the theory we are using is even from outside. Some of the theory are they applying to Africa. So when you run a result with your Africa data, it didn't apply. Will you reject your research? So go ahead and explain. But if somebody on the page has something to add to it, the person can also add to it. We are all learning. But for me, I will support that. Go ahead, don't reject, go ahead and explain it and create a novelty out of it. Thank you.
Oh, okay. So just a follow-up. In case a reviewer makes a comment about you the theory not aligning or you changing the theory, do you try to answer and justify, or you just...
So that is your contribution to literature, right? Contribution of your paper to literature, right? Have a session for it and write contribution to literature, and then write that statement, your statement over there. In your thesis, in your paper, let there be a contribution to literature. By in thesis, we call research novelty or research innovation. Some universities will prefer innovation, some universities will prefer innovation. So you can have a space for it and write it. Anybody here can also help in case you have any ideas.
Yes. I think you've said it all, but we have to tread cautiously on that arena, because, for example, if I'm a reviewer, I know the law of demand and or slow growth theory, and your results is something far away from slow growth theory, and you are saying that is what underpin your work, and none of your results is pointing to that, and you're justifying to me that is your novelty. I will definitely not be kind to you on that score. But if some of your variables are pointing to slow growth theory, but maybe your key variable or a particular a priori expectation is not met, fair enough. Now you can label it and say, oh yes, they could be your contribution. But if a majority of your variables that you are measuring are far away from the basic theory, and you are backing that is your novelty, to be honest, if you are my student, I will tell you, maybe you have to go back to economics class again. Yes, some may differ, but not all your variable. That is what I want to add.
Yes.
Yeah.
Yes. I like the part you came in. Not all your variable. If all your variable are against it, then go back to your data. One. Some of your variable can stand against. It's okay. Okay. Mr. Martin, do you follow?
Yes, I get it.
Okay.
Thank you so much.
Okay. You're welcome.
I think Joanna also raised her hand.
Yes, we can.
Oh, okay. I also wanted to share one theory that I was reading this week, resource-based view. So the first person who proposed it said that when you have the resources, the more resources you have, the more competitive advantage you have over the others. But later, someone also did the same thing. But the person also realized that it's not just having the resources, but how well you utilize the resources. So maybe if it's a build-up, I think if it's a build-up, then it can be the novelty like you mentioned. If it's building it like it's the same line, but now something has to be done, or like the way this one was. So now it's not just the resources, but how you use it. But if like the other person also mentioned, if it's totally deviating, then I think they will question if the theory really explained the relationship.
I like that. So with your resource base, you go to the merchandise theory, mercantilism theory. They all talk about resource base. They all resource based theory.
Okay. So maybe since we have the scholars here, I can just briefly share the theory and then what I used it for. Okay, so the theory is technology acceptance model.
I think it's been recorded, so I don't know if it's recorded.
Okay.
Do you mind if we go out there for you?
Our class is ended. Our class is ended anyway. on the technology advancement theory, and then absolutely
technology acceptance
theory. I'm familiar with those theories. So, Mr. Molly, Dr. Molly, you can close. You can end the recording for now.
I'm not the
Mr.
one
Martin,
recording.
wait first. Please,
Yeah.
anybody have any question before
I'm
we
not the
go
one
off the
recording.
Yes, sir.
recording?
Yes, sir. I want to
Yes, please
ask.
come.
I want to ask.
Mr. Martin, wait a moment, okay?
On the generalized linear
Okay.
models, do we have to also go a step further by checking the robustness, or that one when we just do the normal one is okay?
I think you can also, yeah, you can go a step further to check the robustness of it. Sharon, welcome back.
Thank you.
All right. Any other question? Then we go off, and then Mr. Martin asks his question, and then we can talk about it when we end the class. If none, Doc, you can please end the recording.